Another way to look at spread or dispersion is by looking at quartiles and or percentiles. So a quartile is just a special percentile. So let's talk about percentiles first. This should be something you're already familiar with, especially if you've taken any standardized tests like the SAT, ACT, GRE, GMAT, that kind of stuff. The Peeth percentile is the value such that P% of the observations fall at or below it. So that would mean that the median is the 50th percentile. So the question becomes, on a test, I give you, instead of your numerical grade, I give you the percentile that you fall into. Do you want a large number or a small number when you get the test back? So take a second to think about that. Well, hopefully you answered correctly, which would be you want a large number. So if you are in the 99th percentile, it means that 99% of the people have a lower score on the test than you do. So you are in the top 1% of the people that scored on the test. Right. So the median is the 50th percentile. It cuts it in half, so 50% is exactly below the median, 50% exactly above the median. Also called the second quartile. So quartiles break the data into 4 roughly even parts. All right, so quartile 1 is the 25th percentile, so 25% of all the data lie at or below that number. The third quartile, Q3, is also the 75th percentile, so 75% of all the data lie at or below whatever that number is. So obviously Q3 has got to be a larger number than Q1, larger or equal to in some strange situations. All right. And then what we want to do is, another way that we're interested in looking at range or dispersion, spread, is to look at the interquartile range. So it's abbreviated IQR. It's the third quartile minus the first quartile. This is one way to help find extreme values, sometimes called outliers in the data. So one rule of thumb, and again, it's just a rough rule, so it's not true all the time, and you might use other rules instead, is to say that anything that's below 1.5 times the interquartile range subtracted from the first quartile, we would consider something that's extreme. Anything that is 1.5 times the interquartile range above the third quartile, we would also say is an extreme value. One on the high end, the other one was on the low end. So in order to calculate percentiles and quartiles in Excel, to do quartiles to get the interquartile range, there's quartile.exe. The exe stands for exclude, so that's the one we want to use. There's another one that's in Excel, but this is the better one to use. The first parameter for the function is the cell range, and then the second one is the quartile number, where it's 1 for Q1, 2 for Q2, quartile 2, or the median, and 3 for the third quartile. There's also a percentile.exe that you can use if you're interested in percentiles. So let's go over to our data set that we've been playing with, and let's do quartile. Let's do third quartile, first quartile, and then interquartile range, which will be Q3 minus Q1. So to get the third quartile, we do quartile.exe D2 through D177, as we're still doing calories, and we want the third quartile. All right, so right here it pulls up the little tooltips down at the bottom. Third quartile, 75th percentile. So 174. So what does that number mean? That means that 75% of the 177 beers that we have data on they have 174 or less calories, right? So 75% of the beers are less than 174 calories. The first quartile, quartile.exe, D2 through D177, the number 1 for the first quartile. 25% of the beers have less than 132 calories, it looks like, 131.75. So the interquartile range is 42.25 calories. That means the middle 50% of the beers fall between 131 calories and 174 calories. So a pretty narrow band for half of the beers, for 80 some beers, right? So this can give us a little more information about how spread out the data is, especially for the middle 50%, between 25% and 75%, between the third and first quartiles. Right. So we could also, there's also the percentile. So if I wanted the 95th percentile, we do percentile.exe, again D2 through D177, and now this takes K and it's got to be a fraction, so 0.95. So 95% of all the beers in this data set have less than 222.75 calories. That means 5% have more than that. So that's looking at quartiles and percentiles, and that kind of finishes up stuff for one variables. We still have a little bit more to do for this unit looking at two variables, which we'll do next.